Hi, my name is Fraser and welcome to Graphic Card Repairs. So today we have something very different. It's a usage guide as to how to use this product, which is right in front of us. So today we have a Honton R-490. That's I hope I pronounced the name right, Honton. This is a rework station. It's a very basic rework station. It just has 3 zones for the reflow. So that would be the top air nozzle, the bottom air nozzle, and the IR plate. Okay, so I will take you through the entire process of how to use this machine. I have been using this particular machine for about a year and a half, and I will take you through as to how or what my experience is using this particular machine. Now, on this particular machine, there is no additional gimmicks or nothing extra where where I can align the board and the chip and things like that. Everything is manual. But this is right at I would say this is a kind of a basic machine in this kind of a category. So let's start with a close-up. Okay, so as you can see, it comes with a top heater. This is the top heater. It also has a bottom heater, that is this one, and it has the IR plates. So these are ceramic plates which heat up the board from the bottom. Okay, now each of these zones can be set separately. Like you can set the temperature for the top nozzle, the bottom nozzle, and the IR plates or the ceramic plates as well. There are, in the electronics repair community, many of them, they don't prefer using this this machine. The reason being, in their experience, they felt that the board flexes, or there are some who have even complained of frying the board off completely, or frying the chip off. Like I have experienced that as well, but over the period of over time, I have learned how to use this machine, because there are not many videos explaining how exactly you need to set this up. When you get it from the factory or from the retail shop or wherever you buy it from, it is not ready, or not ready at all. It cannot be used directly on any board, and it's guaranteed that it's going to fry your board, because the main thing here is things are not calibrated. So the first thing what you would do when you get this board is to calibrate this machine. I will take you through the process of calibration on how you can calibrate this machine and how exactly you can use this machine as well. So this is not a paid review. I have bought this machine. I've been using this machine for over a year and a half. And it's just my experience using this machine that I would like to share in this particular video. So I've been repairing graphic cards for over 5 years now. I've just created my YouTube channel about 2.5 or 3 months ago. So let's go ahead and see what we have on this particular machine. Okay, so looking at this machine from the top view, okay, you have this bottom heater. Now the bottom heater has this adjustable cone and it's netted, which can be adjusted. Now the thing here is this is height adjustable, so you can increase the height or decrease it depending on the way or how shallow or high your PCB is going to sit. Yeah, these are interchangeable, and you can use something like this, which is a much larger. So this I would use on a 3080, 3090, and a 4090. This is a 55 millimeter. cone which sits at the bottom, and you also get one for the top. Okay, so this is 45 by 45. So these are usable with something like a 3070s, and everything down below, and something like a 55 would be usable something with 3080 and above, like 3080, 3090, 4090, things like that. So looking at at this view, so you have these IR plates or the ceramic plates. These are each, I think, about 300 watts each. Now, the thing is, when you start off the machine, these start off by default. That's 1, 2, 3, 4. These four start off by default. You can control whether to start the corner ones. That's one here and one here. You can choose whether to start them or not. But for the IR, when you start it off, these will start by default. Now, each of the temperatures on each of these can be controlled. This one can be controlled independently, and also the timing can be controlled as well. So I will take you through the entire process, and we'll continue from there. So this is the panel to control this particular machine. So it has, I think it's about 6.5 inch or 5.5 inch, sorry, 5.5 inch screen. And the controls are, you have these directional buttons to move up, down, left, or right. And you have the M button. M button is just like an OK button to select. At the bottom, you have start, stop, and the light button. So basically, it's very simple. Nothing, nothing complex or nothing that would have a learning curve. And basically, it's just things that you can select. So for this particular model, you cannot connect it to a computer. Everything that you would set, the temperatures, the timing, is from here. Initially, I felt it would have been, or it was very difficult. But as I understood this particular machine, I felt it was very easy to to set this one up. So I will turn the machine on. Okay, so after you turn on the machine, this is what you would see. You have the three zones that they would call it, or the three stages or three zones. The top zone that you see here is for the top heater. This zone is for the bottom, and this zone is for the IR plates. Okay, so it's very simple. You can rename this whatever you would like. There are 9 numbers, total of 10. So it's from 0 to 9, just 9 presets that you can set, or you would get about 8, pre-installed or pre-programmed presets, and 1 they have left it for you to customize it. But what I have done is I have reprogrammed most of it for as per my usage, and that's what I would suggest you do it as well. Now, the first thing first is, when you receive this particular machine, I wouldn't suggest you try it out on a new board, okay? Because it is going to destroy your board immediately. So the temperatures that you see here are actually, you see it on the higher side. That is, and some you see on very low. For example, for a leaded solder, it's showing. This is not for leaded, but this is I use it for leaded and unleaded. I have to set a separate one for leaded. I have to make the changes. It's just that I did not bother. I have a couple of pre-programmed, which I tuned it myself. Now you can see there is a lot of difference between the temperatures that you see here and what they are actually supposed to be. So you would be wondering, why is it 275 on the last stage when 275 is like too much. Trust me, your machine, even though the temperatures that it will shoot out at the at the nozzles is not the same what you see here. And that's why many of them, or many of you guys burn out or fry your chips. So how do you, I will show you the presets that you would normally see. So you would get something like a code, and the default code for this machine or any machine like this is just 1 2 3 4 5 6, but I don't need to change. So what I will straight away do is show you the factory one. There is a factory one which I haven't made any changes to. Okay, so and then once I'm on that program, so I have moved from 1 to 0. Now this is the factory one which I haven't made any changes. Okay, so I will press stop. So this is a factory preset that was there. I left it the way it is, just thinking that I knew I would be making a video someday, and that day happened to be today. So this is what your factory preset would look like. They would have a set time, a set temperature, and you would normally find the top and the bottom having the same kind of temperature, which is a good thing. You should have the top hot air nozzle and the bottom more or less matching it. The IR plates is just to warm up the rest of the board and not to actively play any part into the removal of your BGA chip. So how would you go ahead and set it up? Or why do I say that this temperature is not the same that you would actually have the air out at? Now I will demonstrate it to you. So currently the temperature over here is 100, 165, 195, 210, and 220. Every machine is going to be different. Even though it might be from the same brand, you might use your own brand. There are thousands and thousands of manufacturers in China who manufacture a machine like this and sell it out in the market. But trust me, the temperatures you see here and the temperature that it will shoot out is not the same. And they are different by miles. So the first thing what you would want to do is calibrate your machine to ensure that the temperatures that your nozzles are shooting out is exactly what you intend to. So I will show you, demonstrate it to you as to what the temperatures show here and what it will shoot out from there. Okay, so to calibrate this particular machine, you would just need a multimeter, nothing fancy, something that you know for sure would have something, which has accurate temperatures. So I'm just going to use this multimeter to calibrate my machine. My multimeter has an option for temperature, to measure temperature. And I'm going to use this thermocoupler just to measure the temperature and calibrate this machine. First, I would make a note of the temperatures that it's shooting here and the temperature that would show on my multimeter. I would make a note of the difference. I would first write down all the temperatures that are here. That's 100, 165, 195, 210, and 220. Okay, so these are the temperatures. I would first write it down, okay, and at different stages. So when my multimeter, or when the machine starts, okay, I would, when the timer is at about 60 seconds, I would make a note of, the temperature that shows up on my multimeter. If it's showing exactly the same, or if it's any different, I would make a note of that, the reading that would show here next to this temperature. And I would do the same for all the readings that are here. So once I know, the temperature that it's supposed to be and versus the actual temperature, I would then know the difference, what this machine is sitting at. So it's the same thing that I would do for the top, the same thing that I would do for the bottom. Okay, so as an example, I would just run one test and show you the difference of what it shows on this particular machine. So it's going to be a bit noisy when I'm doing the test, but it's okay. I will try to cover up the noise in post-production as much as possible. So I would turn on the light just in case if I need to. Otherwise, if I don't need the light, I'll just turn this off. So it's just a matter of on or off, and the light would turn on or off. Okay, so let's start. I'll just keep this at the side so you can view both the temperature here and the temperature here. Okay, so before I run into testing the temperatures, I would like to show you these things here. Okay, now if you see here, there are three things here. One is rapid, temperature, and time. Okay, so rapid is how fast your machine will try to achieve this temperature. So like for example, in this scenario, the rapid is set at 3. That means it will try to achieve this temperature in 3 seconds. So that doesn't mean your board will be at this temperature in 3 seconds. That would mean that in 3 seconds, this machine will shoot out at 100 degrees. That theoretically, that's what it's supposed to do. But is it actually doing that? We'll find out. So currently the room temperature is at about 22, 23 degrees. And we are going to do the test. Okay, so same thing with time. Okay, so for time here at the bottom is for how long will this machine hold this temperature before it moves to the next stage. So for example, in this, the first stage is it will shoot to achieve 100 degrees within 3 seconds and then hold it at 100 degrees for about 60 seconds before it moves on to the next stage. And so right now, this preset has 5 stages. So you have on this particular machine, you have an option to set up to 8 stages. The things that you can set is, the stages, the temperatures, and the fan speed. So these are the things that you can set on this particular machine. So different machines will have more options. For example, if you have a higher version which has a calibration of the matching of the points and things like that, you may have it something different. But this is a very simple and basic one. I will, show you the rest of the things. Moving forward, I will now show you the difference that a machine like this would shoot at. So currently, the first 60 seconds, I will show you. Even I will not make a note of it right now. I already know what this machine is achieving at different temperatures. I've already done the calibration part. And based on that, I have the second preset edited it myself. Okay, so looking at this particular preset. So currently this machine on this preset is set at 100 degrees for 60 seconds, 165 for 45 seconds, and so on. So let's take a look. Okay, so I'll have to calibrate these two. It's not required to calibrate this one. It's fine by me. It's not important. It just helps or aids in warming up the board. So you won't have to calibrate this, but you will have to calibrate these two because these two are directly aiding in removal and installation of your GPU chip. So or your memory, if in case you want to use it for memory as well. So I will show you what I will run this machine now. Okay, so I will go ahead and test the bottom one first because it's much more easier for me to test the bottom. And when I test the bottom, so you will see that the temperatures set, the preset is the same, but then you will have to manually adjust depending on the variations that you find after you do your calibration. Okay, so first thing first, I would calibrate my bottom heater. So I'm going to hold it here. I'm going to focus the camera back onto the LCD panel so you can see the LCD panel and the multimeter, which is currently measuring the temperature. Okay, starting the machine now. Okay, so you can see that 100 degrees is just about 4 degrees higher, 4 to 5 degrees. It will now do a switch. About 10 degrees. So the temperature right now, it has to aim is 165. So you can check at the bottom here, the aim temperature, it's gradually increasing to this one, 165. So it's supposed to be 165, but you can take a look at the temperature, the multimeter there, it's almost about 200. So you can see the temperature difference is about how much? 65 and 200. That's 35. That's a 35-degree variation. So which is not good, because there shouldn't be this much variation in your temperatures. And that's the temperature of the hot air that it's pumping out. So now at this stage, it should be 195, and you can take a look at the temperature. It's already at 250. So that's about 55 degrees variation, which is a huge margin. Okay, the next aim temperature is 210. And let's take a look where the bottom temperature rises. So you can take a look. It's supposed to be 210 right now, and the current temperature is 270, which is not good at all. Okay, so right now we are aiming at 220, and the bottom temperature is at 276. Or 78. So we have about 10 seconds for this preset to finish. So you can see the margin of error is really huge. So right now it's cooling down the machine. So it's blowing air. So there's hot air that's getting blown into, over the machine right now. It's an automated process. Once the system is done with its reflowing, or it will then go ahead and cool it down. Okay, so let's take a look at the top one. Okay, so the way I tested for the bottom one, I'm going to measure for the top one. Let's start. So what I'm doing now is I'm holding the temperature probe right at the bottom of the nozzle of the top heater. Okay, so for this particular machine, if we check both the temperatures, the top temperature is off by 10 degrees when we are measuring from 100 to 220. And the bottom, the variation is from 5 degrees right up till 60 degrees. 60 degrees on, sorry, 50 degrees here. But when I measure the rest of the presets, like measuring about 225 or 245 and 255, the variation is 60 degrees at the bottom for this particular machine. So you would have to measure the same thing or calibrate it the same way for your machine, the bottom as well as the top heater. You will find variation. The variation can be anything between 5 degrees to 50 or 60 degrees, and that 60 degrees can make a lot of difference between removing the chip or frying the chip completely, and also destroying the PCB board. Okay, so the next thing what I would like to show you is my preset. Okay, so I'll just show you my preset now. Okay, so based on the variations that I found on my machine, this is what I've created for unleaded solder. Okay, so this has six stages, and this preset I use for the 3070s, the 2080 Ti's, and everything down below. Uh, I use this particular preset, and it serves its purpose well. I can also use the same preset for anything unleaded. For leaded, I have a different preset where I don't need the sixth stage. For me, the fifth stage is more than enough. Based on the variations that I found on my machine, I have calibrated or I have set these temperatures to match the temperatures that I require. So, for example, I have set this at 108 to achieve 100, uh, 200 to achieve 165, and so on. So that's for my machine. So you would have to find the actual temperature difference that for each stages and set the temperature as required for your machine. Okay, so to place your PCB, you would place your PCB in this angle. So the board should be in this direction and not the other way around. Because if you place your board in this way, with the heat, the center portion will sag inside, and this chip you will not be able to install it properly. So in the best way to install your chip or to install your board on this particular machine is in this direction. So it's easier and it will, it's much more, your board, your motherboard or the PCB will remain flat and easier to install. So you just have to move this and your system is ready. So this is exactly how you would use this particular machine. Now you can take a look at the different two videos that I have produced where I show you exactly how I remove and install this particular chip. So this was just a simple video to show you how exactly I use this particular machine. There was a lot of discomfort within the repair community to use a machine like this, because their fear was that this particular board or this, machine sags the board when installing because of the heat applied. Two things very critical when using your graphic card to remove and install the chip back again is one, you have to calibrate your machine before you use the machine, and calibrating would the difference would be you would either kill the board completely or the chip completely. That's how critical it is. So calibrating your machine first. Number two is placement of your board. Your placement of your motherboard or the PCB should be in this way, just the way I show it over here. This way it would be much more easier for you to install it or remove your chip and put it or install it back again. So that's about it for this particular video. I hope you like this particular video. It's just a repair. It's not exactly a repair guide, but it's something. There was a request that was made to show how to use this particular machine or to make a video on this particular machine. It's a very basic one, but it's very effective. I use this machine a lot. Initially, I had the fears that I would burn it. I have fried a lot of boards like this in the past when I started off with this particular machine. But as I learned to use this one, I understood how to actually tune it, because initially I did not. There were hardly any videos which were there which told me what I need to do when I get this particular machine. So I've fried a lot of chips. But luckily those were the chips where during the time when I was buying the chip, the PCBs, repairing and wanting to sell them off. So I've lost a lot of money in return, and but over the period of time I have learned how to use this particular one. Please hit the like button, like, comment, and share. I ensure that I respond to almost every comment that you leave in the on the video. Please share, and thank you for watching. Have a good day. Bye for now. Cheers.